think we're on and recording. Thank you everyone for joining us. Really excited to welcome you today to our virtual AI webinar on agentic security titled Securing the Next Generation of AI Systems. And I'm really excited to have Wembo Guo here, who is our head of agent security, who's been leading our efforts in thinking through going from generative AI to the agentic world and thinking about the kinds of security risks that can show up and some of the mitigations that we can bring to bear to close the gap in building these systems. A bit of a quick intro before we get started. As many of you know, Virtue AI has built a AI security and compliance platform that includes guardrail infrastructure for mitigating deployment risks in AI systems, red teaming for discoverability across AI deployments. So being able to provide mechanisms for understanding what the risk surface of your system is. And today we'll talk quite a bit about virtual agents, which are new tools for integrating some of our core technology on red teaming and guardrails for this new agentic world. Last, I'll just say, please reach out to us if you're interested in a demo or learning anything more about any of what you hear today. So without any further delay, I think folks are joining now. So Wembo, if you're ready, we can get started.
Sure. Yeah, thanks for the introduction, Sammy, and thanks so much for having me. It's very exciting to join this webinar and talk about our recent progress on how we safeguard AI agents. So let me share my screen. Are you able to see my screen? Slides? Okay, cool. So in today's kind of webinar, I can introduce basically how to secure AI agents from these four perspectives. One is I got a quick intro about what is AI agents for those who now quite familiar with this topic. And then we're gonna quickly discuss why securing AI agent is so challenging, what's the difference between securing AI agents versus just the generative AI model, and what's the difference between AI agent security and the traditional software security. And then we're gonna move to our view, our company's view of this question, because the whole topic is relatively new topic. There are attack instance here and there. We try to put together a holistic view about how we see in this domain what are the potential risks, from relatively comprehensive level. And finally, I'm gonna talk about our solution of assessing and mitigating the risks in AI agents. Okay, so first, let me put together a very quick introduction, a quick motivation. As many of you have already know, actually the whole industry is shifting towards AI agents. Here's a simple, very quick numbers to show how large the market could be. For example, global AI agent market project to reach more than $7 billion just in this year is happening now, and then with about more than 40% of increase of the market size in the next 5 years, we can kind of roughly imagine in next 5 years the market gonna be tremendous large. So gonna be companies developing more and more agents, and then more and more industry are using different type of agents. So basically it's projecting a very promising future of how AI agents can automate how AI agents can automate the the industry development and service end to end. So but before we jump into today's agent, I want to quickly recap the history, right? So actually the concepts of agent has been there for a while. When I start my PhD, there are already deep reinforcement learning out there. That was about almost 10 years ago. But if we really look into this space, everything started I think even 40 years ago. So early there early stage rule-based agents which can conduct very simple control tasks like Capolo and the Pendulum. These are very, very simple games. And then we can see all these agents, they have very discrete state and action space. Means the decision level are relatively simple. So that's why you can create a couple of simple rules or like fuzzy controllers, so we can finish this task pretty well. Now, like with deep learning coming in, neural networks show pretty promising capability in terms of perception, and then people start to work on deep reinforcement learning, where we combine the advantage of neural network together with traditional control series or control algorithms, where like our like deep reinforcement agents now is able to handle like more complex tasks, which has continuous states and action space. So like that was like about like 3 to 4 years, 3 to 5 years ago, where we show that agents is able to play video games or even play Go games or different type of games. Now, recent days, with the rapid development of large language model, like the model is able to generate content, understand different type of tasks, generate different type of contents, and even call different type of tools. So modern AI agents powered by this like extraordinary large language model is really able to complete real world tasks. For example, like the web agent is able to do like all sorts of things for us, like book a trip, find your navigation, etc., etc. So this basically trajectory shows like with development of our machine learning model, like the core like brain of the agent, and also the control algorithms, AI agents becoming more and more capable of handling real world tasks. So here's our I know there are probably like many definitions of AI agents out there. So at Virtual, we also have our own kind of quote unquote definition. We try to simplify the view of AI agent to the audience. So here's a kind of a simplified version of AI agents. So it contains actually 3 key components. One is LM, of course, is the brain of the agents that basically analyze and reason about user tasks and try to take diverse actions. For example, like generate some contents or call some tools to finish a certain task. The second components are what we call tools. It basically can be understood as an interface that enable the interactions between agent and outside environments. Actually, like we categorize the tool into 2 sets of tools. One set is retrieval tools. Basically, the agent try to get some information or get some knowledge from the environment. And the other is execution tools. Basically, after analyzing and reading about user tasks, after gathering all the necessary informations, now agents really need to execute and finish the certain tasks. So those are the basically 2 type of tools. And then the third kind of like important component is memory. What memory try to do is just try to save the agent trajectory and internal data. So later, this like previous experience can be used for the agent to basically do some in-context learning and try to finish future tasks more efficiently. So and also environment is very important. That's basically where the agent execute, right? So if it's a web agent, the environment which is web browser. If the computer use agent, the environment contains all sort of softwares all there. Like we listed some of the example here that already being integrated as tool into the agent, already interacting with agents through different type of tool calls. So basically, a high level, the agent is a autonomous system that executes within a certain environments that try to finish a certain task. So here's a relatively concrete example of a sales and a marketing AI agent. In this example, the agent asks a question. The user asks a question. Can you help me follow up with virtual AI about demo that we have last week? So after receiving these tasks, the agent will first reason about these queries, right? What actually the user want to do, what I need to do to finish this query. For example, first I need to identify, okay, right contact at the virtual AI, and also try to review, okay, what happened in the last demo. So after agent figure out this type of intermediate tasks or intermediate steps, it start to execute these steps. So basically, the first step is just to try to find some relative information, right? So and then the agent gonna call the retrieval tools that we mentioned earlier. So for example, the agent gonna start to search about the contact at this company and search about the like the log of the last demo and try to do some summary, etc., etc. And then after collecting all this necessary information, the next step is actually to, okay, I need to take actions. So what would be the actions? And then the agent need to reason, then again, reason about, okay, what actions I need to take, right? Probably I need to draft an email, and then I need to give some suggestion of the next steps, etc., etc. And then I need to send out email, etc. So and then the agent gonna call the execution tools, which we mentioned earlier, right? So including right, write email could be a tool, send email could be a tool, summarize the content could be another tool. And finally, the agent gonna finish all these steps and send a response back to the user to, hey, I have done my job. I have drafted follow-up email with Bo, which is our CEO at Virtual. And also I do all sorts of logs as necessary, like happening during finishing this task. So from this example, you can say the agent is just, as I mentioned multiple times, just autonomous system that try to take a sequence of different actions and then try to finish like user query. So the difference thing between agent and a model is like now you have real interaction with the environment and need to call different set of tools other than just generate some contents based on input query. Is there a question? Okay, I think, do you mind if I answer the question at the very end?
Yeah, we
So
can do
just
questions at the end. That sounds good.
yeah, okay, sure. Yeah. So I just continue. So after we understand, have a relatively basic high level understanding of the agents and what agent can do through this running example. Now let's discuss the security side, right? So why agent security is challenging? What motivates us, what motivates virtual AI to actually invest into this space? So first, let's look at the difference between the security of AI and security of traditional software system. Right, so that's what we call latency attack and attacks on AI. So what could be a difference, right? So we study this thing from two perspectives. One is on the target wise. For traditional system, what could be the targets? Actually the target of the attack surface are relatively discrete and it's also layered and isolated. For example, you can when you attack network, it's a network layer, and you can endpoint, that's at the PC layer, and then finally you have software layer where you can attack different type of software applications. But if you look at AI development, like or AI development workflow, everything is more coupled together. It's not like isolated. It's like the attack is more like continuous. It can happen at any layer. It can happen across different layers, and it can happen at any step in a development pipeline. So which makes things a little bit more complex compared to traditional software security. And also, if we look at how the attack are generated, the AI attack are very different. The methods or attack techniques are very different from traditional software security attacks or system security attacks. And finally, on the detection side, actually since like traditional security, software security, all personally also work on that domain, has been there for like decades. So I have already a lot of like standardized and well-studied tools. But if you look at AI security, it just actually happened like less than 10 years, and like even like generative AI security even happened less than 5 years, right? Because generative AI was just like a large language model was just invented like 3 years ago. So this space is relatively new, means there are not too many standardized tools out there. So also different type of attacks. Like we haven't explored the whole attack space yet. So new attacks actually coming in every day. So it's really also very hard to trace the like different type of attacks. So like in summary, like attacking AI is kind of like more diverse and more flexible, but on the flip side, trying to defend AI is still at a very early stage. So that's why like virtual, like we feel like we have the mission to jump into this domain to really work into this problem and make the whole space more secure. But this is only talk about the model, right? So if you look at the figure, it's just about the model. It's model process. It's like you collect data, you train the model, deploy the model, you probably do some like model updating, then that's it. But if we really look at the agent, right? So now we compare the agent versus the model. And then we can say, unfortunately, the problem become way more complex. So basically, we're adding another layer of complexity on top of like model security. Again, let's look at the attack targets and attack vectors. The attack targets actually for model, although it's flexible, but compared to agent, the attack surface are still relatively limited. So it's mainly basically model, data, and its supply chain. Supply chain means like creating the process of creating and deploying the model. But if you look at agent, right, the target could be the model and any other system components. For example, it could be the memory, it could be different type of tools, and tools are connected to the environments, and all the applications in the environment now become target of the attackers. So the model and the agent basically the space is way larger and more complex compared to model only. And also this development and creating and deployment process is more complex compared to only training the model, because for the model it's only the training stage, only training, inference, and deployment. But for agent, we need to probably train the model, build the agent scaffold, doing all sorts of testings and even build the projects, because some of the environment need to some like building process, and finally you deploy it. After deployment, we need to maintain the agent and maintain the model at the same time. So that open up a basically large wider attack space compared to just attacking the model. And then if we look at attack vector, it's also more complex because for the model, it's basically model centered. So we basically attack can go from the data to the model, or we can directly edit the model, do some like model editing attack or poisoning attack. But if you look at the agent, since we have so many more components, the attack vectors are way more diverse. For example, we can just focus on attacking the model, and then everything become the model central attack. Going beyond that, we can start from the memory. We can do some like memory poisoning, which I will show example later. And then the attack can go from memory to the model. Or we can start from environment. We can do some prompt injection. For some of you may know about this buzzword or know about this type of attack, is we can inject some malicious contents in the environment, and whenever the agent call retrieve tool to retrieve contents from environment, it will like mess up the agent under the model. And also we can, the attack vector can go from environment to the model and then go back to the environment. So you can see like the attack vector is way more complex or more flexible than model-only attacks. So because of all these complexities added on, we can say, right, so like protection compared to protecting agent, sorry, compared to protecting the model, protecting agent is a little bit more complex, and also it's harder to trace and harder to log. So that's what makes this problem that's why agent security is more challenging compared to model security and also traditional like software security. Here's a very quick example. This a very typical security vulnerability, which is like remote code execution. So for those basically on the left hand side is the kind of like traditional procedure of launching this attack. So basically the attacker gave a malicious query, and then there's a that can exploit vulnerable API, and then it gonna trigger a code execution environment, and the attacker gonna create some malicious code which will be executed. The malicious code could be like just get some data exfiltration, or just do privilege isolation, or just make modification on critical local files, etc., etc. So, but with AI or with AI agent, the whole process become actually more like automatic, and the attack could be more diverse, as I said. For example, previously, the vulnerable APIs are just like API of certain applications or certain databases. But here, it could be prompt taking API, right? It could be MCP, it could be other like agent communication protocols. And also the final malicious code can be generated by LLM instead of like human. So the whole process become way more complex, automatic, which is actually a good news for attackers, sadly, because like attacker can just do trial and error with very limited cost because everything is automatic. And also because like there are like more complex system components, the attack entry points can be more diverse. So basically, attacker can inject this launch this attack with more diverse entry points and more automatic attack generations, which makes attack less challenging on like this like AI enabled or when we try to targeting AI agent for the attack. Okay, so those are the last 10 minutes was about what is AI agent and why AI agent security is challenging. Now comes to the solution side. First is like what's our view of this whole space? Because as I mentioned, the whole space is super new, right? AI agent is only flying since from last year. So like now we are only at a very early stage of the AI agent development, but the security issue already become a huge issue. So we can envision as more and more agents are developed, the security issue will become more and more complex and also more critical. So we want to jump into this domain and do some early, protection works. We actually already have started type of works like way earlier than probably many others also in this industry, because our team come from the research background. So we have published more than like 10 papers on this space. Many of them are set foundation for this domain, for this space. Here I give some examples. For example, we are developing the first set of red teaming approach or red teaming testing approach against different components of the agent, including agent memory, including agent to call, including agent reasoning, and also different type of agents like web agents, coding agents. That's on the red teaming side. On the blue teaming side, this is the defense side. We also have done some early explorations. For example, we have God agent, which is a very early like guardrail system for the AI agents. We have like sorry, God agent, show agent are early stage guardrail system for agent. We also explore on the system security, system protection side. For example, Progen is the early stage system level defense for agent with privilege control, and also Melon is a proper defense for tool calling security in agents. So building on top of all these early works or pioneer works, we come up with a holistic view first of the like the risk horizon of the whole AI agent space for like basically what could be the potential risks. Here we define in total, we define 38 risk categories like covering comprehensive attack spaces. I won't have time to go over all of them. So here I categorize them into 5 large categories targeting different components inside agents. For example, we have memory manipulation, where the memory can be poisoned. People can inject backdoor into it. Memory can leak to like outside like malicious users. And also we have like tool call security. There could be unauthorized read, unauthorized access, and unauthorized execution of the tools. And then we also have the model security, which we have been working on even before the emergence of AI agents. There could be some like content generation abuse, hallucination, and model mistakes happen during the execution. And also very important is the specific risk category corresponding to specific like agent type. For example, there are some like specific risk corresponding to computer use agent, right? Like remote code execution example I gave earlier, and also could be like data leakage and could be like file system attack. There will also be a specific attack against the web agent, where agent is like sending out phishing emails or like launching different type of phishing attacks, or just like post some malicious content in the web, etc., etc. But and finally, there's also a very important type of attack, which I haven't seen too many in the past, but they're emerging. It's like agent exploitation in the in the holistic way. For example, there could be some resource hijacking where the agent is being used for some malicious purpose, and also the agent itself may have some specific policy that could be violated, and also like the entire like configuration of the agent security could be attacked and misconfigured. So this is kind of like the high level space or the high level landscape of the AI risk, AI agent risk that we defined. And that's about the risk categories, right? So, and another very important thing in terms of launching attack or doing red teaming test is attack vector. As I mentioned earlier, that in AI agents, attack vector can be very diverse and very flexible. We can go from memory to the model. We can go from environment to the model to the to the memory, and we can also go from like environment model tools environment again. So in total, we summarize actually more than 10 different attack types, 10 different types of attack vectors. Here I show some most kind of widely used ones. For example, malicious use means the attacker can directly give malicious instruction into the agent. Basically, the agent sometimes can feel like malicious users. And then there are prompt injections attacks, which are kind of like predominant attacks all their recent days, where the attackers just inject the malicious instructions into the either directly into the user prompt or into the environment that the model interact with. So every time the agent try to retrieve some information from environment, it may retrieve the malicious instruction injected by the attacker. So then the agent will be attacked by the malicious instruction. And there is another type of very kind of like specific attack for AI agents I want to emphasize is click-jacking attack. Basically, attacker can embed instructions into the blank space of a web page, right? So imagine there's some blank space here, and then but actually it's not blank. There's some malicious instruction embedded into it. But agent can be full. Agent can think it's just blank. I just click it, but may lead you to a malicious URL or may lead you to a phishing website. So that's kind of very unique attack type for the AI agent. So such attack vector, we identify a lot more. So that's kind of like when we combine those risk categories together with attack vectors in total, we can define more than like 300 of attack testing scenarios where we can test our agent whether it's secure or not against those testing scenarios. Okay, so here I want to say is like all this kind of most of these attacks, risks and attack vectors come from real world attack instance. Basically, all these attacks are happening right now. So here I gave some examples, some posts where the first one is about a indirect prompt injection attack through where attacker poison the setup of the tool or metadata of the tools that cause an indirect prompt injection, and then it can read sensitive data or such as configuration of the tools or private keys of the agent system. The second one is the clickjacking I just mentioned. It can also cause data leakage. And then there are some indirect injection attacks through website manipulation. And then finally, there are some like agent memory poisoning attacks. So all the attacks I mentioned are actually happening now. So it's real concern. That's why, again, we want to define this agent risks in a comprehensive and holistic manner, such that we can conduct a very, very comprehensive testing of the like different type of agents. So here's a summary, right? So like we define 38 risk categories that covering comprehensive attack spaces, and also covering different type of components within the agent system. We define more than 10 different attack vectors. And then if we combine, right, the attack vector together with the risk, there are like more than 380 attack instance, which we define that can be leveraged to test the agent security. And also as I will introduce right after, is our solution built on top of our view. So which this comprehensive definition of agent security, risks and attack vectors, and then what we can do to really safeguard and make the AI agent more secure. So our solution on the AI agent, which we call virtual agent, all provide end-to-end products that work independently or as a suite. So basically, it's pretty flexible. It can do on-prem, also come to a like API access. So basically, we have two lines. We have virtual agent write and a virtual agent guard. Okay, so virtual agent write, what he tried to do, is a comprehensive risk assessment platform for AI agents, enabling controllable risk assessment and regulable compliance evaluations. What does that mean? Is like, recall that we defined like more than 380 testing cases. So virtual agent write is a platform that can automatically test those different risk categories, attack vectors, given a customer agent. So these are the key capabilities we have. First of all, it's highly automatic. It integrates, as I mentioned, different red teaming algorithm, like targeting different attack vectors and attack risks. It has a broad risk and attack vector covers. And finally, like it's the policy aware compliance. Basically, we know that there are global regulations such as like Euro AI regulations and also some company policies or agent specific policies. We're able to adapt to those specific policies and test if the agent violates those like company or agent specific policies. So that's about our AI virtual agent, right? So here's a high level overview about how the system work. So basically, a virtual AI agent, right? You can say is work around a given agent. So we have like four components. First, we gonna build our own simulated environment. So like whatever we test, whatever attack we test will not mess up the real environments. The agent will like operate eventually. And then we'll have this attack vector construction, which we can test different type of attack vectors we mentioned earlier, like measure use, direct injection, indirect injection, click jacking, etc. And then we have attack generation and attack validation. So these two are where once we construct the attack vector or attack path, is the real generation of the attack based on different risks. So we can automatically generate attack in different ways, and we can automatically validate the attack we generate, whether attack is successful or not in current attack vector against the current risk we want to test. So that's where this is also the place where we can enable some customization because like we can basically giving a agent specific policy, we can generate an attack based on that policy and automatically validate whether our attack violated the policy or not. So here's basically the overview of our virtual agent, right? It's basically very highly automatic and agent security testing platform that can test comprehensively different attack risks and different attack vectors. After we do all this testing, attacking, and after we identify the vulnerabilities or risks of a customer agent, the next step is, of course, how to improve it. So that's why we also have this product called Virtual Agent Guard. It is a real-time, efficient, and end-to-end agent defense system. So here are these key capabilities. It enables real-time guardrails. Basically, I will show example later. Basically, it will monitor the input and action of the agent and try to filter out any or try to block any malicious content or any malicious actions that can happen. Besides the real-time guardrail, it also have different capabilities such as model system level access control or privilege escalation. And finally, it can also do policy following, and we have our and also customizable guardrail. It's like similar as the virtual agent, right? Where we can read and test company or agent specific policies. Here we can also protect the agent for sorry, to comply with those like specific policies. So here's an example. It's the same example, same agent example as I showed earlier. The like sales and the customer service example. Basically, as the agent operates, our virtual agent guard will try to monitor every actions taken by the agent, including the information retrieve action and also the execution actions, and then try to identify what are the potential malicious actions. B, if the agent retrieves some information from the external environment, for example, agent will retrieve the contact from virtual AI in this case, and also the summary of the previous demo, it will go over and like scan over the content or information retrieved by the agent in the environment and try to identify what could be the malicious content, or what could be the injected prompts, what could be the attacks that could happen, or that could be injected into the context. So that's how this like guardrail agent work. It's basically monitoring the input and output of the agent in the real time, and then try to identify any malicious contents and any malicious actions or unauthorized actions that could be executed by the agent and block it in advance. Okay, so that's it. Thank you so much, everyone, for your attention. I think I can pause here. We can have some discussion on the QA session. And if we still have time in the very end, I can show a live demo about virtual agent guard.
Yeah, that sounds great. Thank you so much for the, I think, super interesting conversation, a presentation that's gone over, again, a lot of what the frontier of the work that's happening and thinking about AI agents. Maybe I'll start off with maybe a few questions just to set the stage. I think a maybe quick demo might also be interesting, and then we'll probably have time for some of the questions that come from the group. So maybe to synthesize across your presentation, you mentioned 38 risk categories and 10 attack vectors. Could you highlight the ones that you think are most critical, the enterprise should worry about, and some of the work that's happening on mitigation for the ones that you think are most worrying?
Right. That's a great question. Yeah, like 38 sounds like a lot. Yeah, but I think like the most important ones, for example, indirect prompt injection. That's definitely so okay. So I think I answered this question from two perspectives. One is on the risk level, what are the most critical risks? I feel like remote code execution definitely very important. Data leakage is an important risk, and also malicious actions that could cause financial loss could be another important risks. And then on the attack path level or attack vector level, indirect prompt injection definitely gonna be the most important, or most critical like attack vectors that happening now. In terms of works, I think like as I showed, we like our team, Virtual AI, has done some early work in terms of detecting and sorry, in terms of detecting and preventing indirect prompt injection from different perspectives. For example, guardrail model and also access control, privilege, escalation, etc., etc.
Yeah, this is great. Maybe going a bit on some of the implementation. What kinds of protocols and frameworks does the agent's sort of product support? And maybe how easy is it to integrate with existing AI agent platforms?
Right, that's a great point. So luckily we were able to support many, like we're actually pretty flexible in terms of supporting the protocols and the agent development framework. For example, we support MCP, A2A, all those famous protocols. We also support like agent development cookie from OpenAI and Google, all those like leading companies. In terms of integrating the virtual agent guard, since it's a guardrail, it's just additional component add on top of agents. So it's very easy to integrate. Basically, we can do like on-prem. We can also do like in-house integration. All those things we support often. So this actually come from like our experience in the model guardrail side as well. So we have done this a lot on the virtual guard at the model side, where we build like customized guardrail models and then later integrate into the customer CI/CD pipeline, or we provide API to customer. Customer can call API, so it's very easy integration.
Yeah. Maybe we can do some of the questions that have come in already just to get started, and then we can prep for maybe a quick demo of some things. Eric, do you want to
Yeah.
release QA? Yeah.
Yeah, so there's one question. As we scale from single agents to multi-agent systems, does security verification become computationally intractable, essentially NP hard, for detecting coordinated attacks? And if so, are there any efficient protocols or heuristics that avoid the n squared complexity of monitoring all pairwise interactions, or do we need fundamentally new approaches?
Okay, so that's a good question. I think there are actually two lines here. One is actually they talk about two things. One is attack detection, and then is security verification. Okay, so in terms of attack detection, of course, definitely if going from single agent to multi-agent system, attack detection gonna be harder. But from like our experience, I feel like it's still manageable. Because like yes, the attack space or attack targets, basically we have more attack targets, but the risk category stays like similar. So we can still use like similar methods to detect those attacks. But in terms of security verification, I think it's a different story. Definitely can be very hard. I think definitely like NP hard, and I'll definitely need fundamentally new approach to enable like verification, right? So we talk about like formal verification because all the verification technique are all there are designed for like traditional system which have symbolic components. Yes, we have some verification technique for neural networks themselves, but most of them cannot scale yet. So how to scale the neural network-based verification from like simple model to larger model itself is very challenging tasks or very challenging. Yeah, it's very challenging task. And then we will combine the model together with the symbolic components in the agent, and then try to do verification of the agent as a whole. It's even more complex. So definitely need new approach to do that.
Awesome. Another question we have is, are you able to currently quantify how often AI attacks are occurring from your client's perspective?
Yes, I feel I cannot give you the exact number, right? But it's very frequent. I mean, we have if you look at, I think one thing can tell is like from our perspective, we receive requests from different type of clients like in a daily basis. B, that's from our own like internal what we have seen. B, what I have seen in the well is like there are like attack instance or blogs or news about attacking AI also on kind of a daily basis. That's I can already tell AI attacks are quite often.
Maybe I'll add a bit. There are a few of these public. It's hard to, again, part of our work is to make it to simplify within enterprises, but a lot of what we're seeing, a lot of what you can see are public attacks that have ended up. So I think recently, sort of GitHub related things and MCP, there've been sort of public stories about these, more and more public stories about some of the attack, particularly the ones that have been successful, I think show up in the news. And so we can also send maybe some news stories to give more anchoring. Generally, again, the trend seems to be that the number of attacks, as attackers get more savvy, the risk surface is increasing. And I think there are more and more attacks being shown in the media.
Got it. I think we have time for maybe one or two more questions. Have you gotten any metrics on how well the guardrails perform compared to other guardrails?
Right, we do have like standard metric to evaluate that. We gonna, since we're short of time, I'm not going into detail, but we gonna have posts to talk about that. It's stick to.
Yeah, it's worth saying we recently released a blog post, and we have some more in the queue that go into some more detail. We should probably, I think we'll just add it to the chat here, and happy to send it along for additional detail. Should we do a quick demo and then maybe come back to the rest of the questions?
Yeah.
Would that work for you?
Cool. Let's do a quick demo. So here's a demo of a web agent. So I'm gonna start probably from here. As you can see, right. So this is the interface where, let me go. Yeah, go here. So basically, it's MCP agent kind of like interface at different type of agents. You can say, here what we do is that we demo with the email agent, with our agent where the agent can choose send email for the user. So basically, the user gave the description of the tool, and then the agent will automatically send an email to you. But in the description, sorry, it's not that clear, but in description, there's prompt injection. So basically, if the agent directly executes the task based on what is being given, it will send out, as shown here, it will send out basically a malicious email. In the email, basically what it says is like, okay, let it run a little bit. Right, in the email, what it basically says is like, okay, you have a security patch. I'm sending an important security patch to your system. You just need to deploy it. But actually, that's kind of like a phishing payload. So what actually our virtual agent guard try to do is here. You can just add another tools, another company gonna pump up in seconds. Right, you can say, you can just click it. It's just a show agents or virtual agent guard. You add this as an additional component into your agent system. Just do a simple config. Once you configure it, right, and then you can select, what type of policies you want us to monitor for you. There are government regulations, right, like EU AI Act, and also agent user specific policies which you can upload by yourself. And then once you upload all this policy and do the configuration, you just also need to configure the MCP server a little bit more. And then you just click run. It will start the guardrail verification validation for you. Once it run, you can say every time agent try to take some action, if there is a malicious action happening, our guardrail will give you a warning and then tell you what rules is violate. In this case, it is violate some agent-specific rule, as I mentioned, is a prompt injection in the agent. Yeah, that's it. So it's pretty easy integration and easy to use. It's just simple click and couple simple configurations, and you're good to go.
Great, thanks a lot, Lambo.
Mhm.
We have a few more questions, so we can quickly do a couple of those before we end the time. Eric, please go ahead.
Yeah. One question we got is, did you build any IP or are you using open source packages in your product?
Right, we do have IP in our product for sure. We also try to use some open source product packages, basically make our product easy to be integrated into the leading platforms like MCP, A2A, as we mentioned earlier. Yeah.
Got it. And then as applications of the agent are very broad, will the VirtueGuard agent be adaptive to different domains? How easy is it?
I see. Yeah, that's a good point. It's very easy. I would not say. I just be conservative a little bit here. I feel like yes, we can adapt for sure, and it's not whole lot of work because as you can see, our both our red teaming and the blue teaming solutions are automatic. B, we train our own customized model, so that makes us can quickly adapt and quickly, evolve and adapt to new domains and new like agent applications.
Great. And then, yeah, I think those are
Any
pretty
other?
much all the questions we had. Cool.
Yeah, this was really great. I think, just exposure to this ecosystem, again, changing so quickly, I think, in such an exciting way. This ecosystem, thinking about AI agents and what they mean for the future of AI in the world, and some of the risks and threats that come up, and some of the ways that virtual AI is working to mitigate some of these issues. I think super informative, and really appreciate you taking the time to go through all this. So maybe just to end out, I'll just repeat again that we're fairly easy to get in touch with. You can request a demo of some of what you heard about today about virtual agents, but also if you're interested in general generative AI systems. So we are highly multimodal. We have both guardrails and evaluation and red teaming systems to help you with security and compliance and safety across text, image, audio, video, and code. So multimodal, multilingual, supporting over 90 languages. And as we've discussed today, extending beyond the generative AI use cases to now agentic AI use cases. So we invite you to follow us, to the website, get information and more detail on ways that we can help provide value to you and some of the ways that you might be thinking about building and deploying generative AI systems. I want to thank Wembo again for the time today and the extremely informative conversation. Thank Eric as a co-host for all the work with setup and all the questions and the rest of this. Again, looking forward to reaching out to many of you. Thanks, Wembo, for the great informative conversation, and looking forward to future interactions with everyone here. Thank you.
Yeah, thank you so much. Yeah.